Now I'm at the WMG department of Warwick University. Now as you'll see, I've driven here today, but in a few years' time I might not need to. And that's why we're here. I've come to learn about driverless car technology. Simon, this is your product, this is your baby, you've built this at RDM. What's the purpose behind it?
Yeah, so this is a last mile transport solution. So the idea of this vehicle is there will be a fleet of these vehicles in the town or city where they're operating. You would call them up with an app on your phone, or you could go to a kiosk and have a ticket. It will come to you without anybody in it. You'll get in it, it'll give you a passcode to open the door, you'll get in it and it'll take you to where you've already told it, where you wanted to go from the app.
So what's the benefit to society, let's say?
Okay, so the idea is that you'd have a fleet of these vehicles that would be running around, and rather than having everyone having their own personal car and then using it for 5% of the time and parking it for 95% of the time, the idea of these vehicles is that they're very heavily utilised and they're on-demand service. So you can move people around in your city. These are obviously electric, zero emissions at point of use, and they will take quite a number of people. This particular one is a 4-seater one. We also do an 8-seater one, and even bigger than that. And they run on the pedestrian precinct areas. So you get in it at the park and ride, and you can drive with it all the way down to the local shops in the middle of the city centre. There's even some plans to drive through some of the shopping malls in city centres.
So unlike a taxi, it doesn't talk to you on the way?
Well, of course you can interact with it. It has a VR system, virtual reality system in this particular one. But
have you designed, you've manufactured, you've done everything? This is solely RDM's product?
Yeah, so we're a little Coventry-based company. We're the same company that did the Lutz Pathfinder vehicles for the Transport Systems Catapult, which is a project that's running in Milton Keynes. So we had a head start because the Transport Systems Catapult nominated us. It was an open engineering bid competition. We won that bid and engineered those vehicles, 3 of them, for the Transport Systems Catapult. With the learning that we had from doing that project and with the growing market that is appearing, we thought, hey, we can do this. We can build a slightly bigger one, so a 4-seater one rather than the 2-seater we built before. We can take some learning and some experiences, and we could go ahead and we have all the different facets you need to build an autonomous vehicle. So we have the engineering of the mechanical vehicle. This vehicle isn't based off some other vehicle. It's completely from the ground up designed for this purpose. We have all the computing technology. We have the control systems. We have the ability to safety engineering. So we've used people like Myra to do a safety analysis of this vehicle and the system.
So the health and safety is a massive one. I mean, tell me more about that. What about this travelling down a road and there being an accident, or how does it avoid obstacles and potential hazards?
Yeah, so the vehicle itself is guided from a pre-built map. So we have a map that's a high-definition scan of the area we need to operate, and the map is created basically without any hazards in it, no people, it just has the infrastructure in it. And then on the pod system itself, we have laser scanners, stereo cameras, ultrasonic sensors, and we also have a safety driver who's remotely outside the vehicle, so basically video surveillance of the system. And we're ensuring that the pods are going at an appropriate speed for the amount of congestion.
Okay, and now I wouldn't buy one of these from you. How's the makeup of who purchases these from you, and how does that work?
Yeah, so the intention is that there would be a fleet of these operated by a fleet operator, similar to a bus company, that kind of model. So they would be contracted by city councils, town councils to provide some transport. And you would only use it on demand. So you use it, you call it on your app, it takes a few minutes to come to you, it then takes you exactly where you want to go, and then it goes away and finds the next ride to take them.
And this is a model, there's no windows in this one, but are you anticipating that a final product would have windows within it?
Yeah, so for some scenarios, actually windows are not needed. So there are some cases where we have a system that would possibly be running in tunnels, so mostly hidden. So people are building new shopping centres, they don't really want the transport directly interfacing with the people, but they do want it to pop out of a tunnel into an open plaza, pick up some more rides, and then disappear again. So for that kind of purposes, obviously there's nothing to see, so there's no point to having any windows. And having a virtual reality inside gives you all sorts of other benefits.
You could watch a movie.
You can watch movies. You could be in the movie. You could be in a 3D game when you're running. You could, play your Minecraft when you're running down to the shops and back.
So some people would rather be in here than on their sofa.
Yeah, I talked to my kids. They would certainly much rather be in this as a big 3D game engine than they would sitting on the sofa only with the one dimension.
Now when are we going to see these? When could we be sitting in one of these going from A to B in a town centre, for example?
So this particular one is the first of a fleet of 40 of them that we are building for an Innovate UK project, which is called Autodrive UK. And Autodrive UK is putting a fleet of 40 of these to Milton Keynes by the end of 2018.
So residents of MK, watch out.
Exciting times for everybody.
What a fascinating insight into a really innovative product. Now, in talking to RMD a little bit earlier as well, I found out that they've only actually been developing the product for 2.5 years. So imagine where it's going to be in 5 years' time. Now we turn our focus and our attention to this simulator. I'm going to talk to Professor Paul Jennings about where this has come from, about what their plans are for it, and exactly how good it is and what it delivers for industry. Paul, it's very exciting to be here today. Just tell me a little bit about WMG, Warwick University, and what we've got here in this simulator.
Okay, WMG is a multidisciplinary department. We work with industry. We're trying to help solve real-world problems so that their businesses will work better.
And the simulator itself here?
Okay, well, we're really excited with the changes in automotive technology at the moment, the move towards smart and connected vehicles, autonomous vehicles, eventually driverless vehicles. And we see that there's going to be huge advantages for everyone. So, for instance, at the moment, 90% of accidents are caused by human error. So, theoretically, we can make life safer. We can improve energy efficiency with more control. Similarly, we can reduce congestion. The average driver spends 235 hours a year behind the wheel. Imagine we could use that time for something more useful.
So in here then, have you developed this simulator here? Is it the only one in the UK or even around the world?
There are a lot of simulators around, but we've got some unique features here. We're particularly interested in being able to test driverless, smart and connected technology. So there are two features that we think are unique. Firstly, we want to be able to test any vehicle, any technology within here, to be able to bring anything in here. So effectively, we're simulating the environment rather than the vehicle. And secondly, when I talk about the environment, that means not just the sights and the sounds and the traffic and the road surface and people. Nowadays, cars are becoming connected, so we need to be able to create the wireless environment in here so that the car can be fully connected but under our control. And so we're built in a screened room which keeps everybody else's signals out, and it means we can keep control of the signals that are in here.
Environmental factors then, is that part of what you're saying here, that a simulator is great, but if you know that in 100 yards time a dog's going to run in front of you, you know it's going to happen, you're anticipating it happening. Is there any way that this simulator is different to that and the random factors can be thrown at you?
Absolutely. So at the moment there are some really exciting trials going on with driverless technology up and down the country. So for instance in Milton Keynes and in Greenwich, and I couldn't possibly take away the value that those give us. But if you imagine in the real world, it's pretty complicated. You can't really control things, as you say, dogs could run out. And actually, a lot of the time, nothing very interesting happens. What we'd like to be able to do is to take those interesting instances and replay them, but in a nice, safe, repeatable, risk-free way. And that's what the simulator is about.
Now, is there any if you looked at it as a simulator where, I was asleep,
Yes.
How would that factor in?
Okay, if you're asleep, then we could actually look at maybe different mechanisms that you might be woken up and how you would respond to that. I think the fact that we put, I hesitate to say real people in here, I think it's important we get customers along, the people who are eventually going to use these vehicles. We'd like to design the technology with them so that they will work with people, but people will then ultimately want them, trust them, and buy them.
Because being asleep, I use that as a very random example,
Yeah.
but people might look at a driverless technology and think, this is great, I can jump in the morning, I can shut my eyes and I can end up in Coventry, but can that happen?
I think there are stages. So at the moment, there's a long way to being fully driverless from journey beginning to journey end. But a lot of people's cars now have got an autonomous feature, maybe automatic braking, maybe self-parking. It is happening. And it may well happen in stages geographically. So for instance, you might get that last mile of the route from the station into the city centre, you might use a driverless car.
I can't begin to think, the people that are behind the development of this, how would they put together two random scenarios, like we talk about a dog walking in front of you, as well as a lady with a pram? So how does the car, does it veer left and then veer right? How does it?
Actually, that's a really interesting point you make, and actually choosing those use cases and scenarios from almost the infinite number of things that can happen in a city is actually one of our first challenges, is so that we can represent a nice broad spread of the likely things that could happen, so that we can test the cars as comprehensively as we can.
Well, I'm going to jump in this thing in a minute and have a go, and hopefully I won't have a smash. But what about learning to drive? Is there a use for this? Could I, in 5 years' time, take my driving test in this simulator and then go on the road having passed?
Well, probably not something we're looking at, but there are lots of simulators up and down the country that are used for driving, maybe for helping people drive more energy efficiently, maybe for, like in motor racing, training drivers. So there are simulators that are specifically designed for that. Maybe ours could be used for that, but it's not the focus.
And similar to the aircraft industry, I mean, autopilot's been regularly used for many, many years, and there's, different, we talk about Boeing and Airbus, they have different ways of using their autopilot. But are you using the technologies from those markets to assist you?
I think it's a little different. I mean, in a plane, there is a trained pilot there as well. Our hope is that just normal members of the public can use this technology, so we do need to think a little differently. So it needs to be usable, and that's why we need to design it with them.
Now tell me about the background behind this. We've obviously got JLR involvement. How is it funded, Paul?
The simulator itself was funded through the Engineering and Physical Sciences Research Council on a capital award, so we were very fortunate to win that award from them. And now we've got projects that are funded in different ways, especially from Innovate UK.
Okay, and you've got some very clever graduates coming through that are part or integral in this success.
We've got quite a broad research team. As you can imagine, there's lots of disciplines that are needed. So everything from electrical engineering, computer science, cybersecurity is a big thing nowadays, human factors, and the business. The business is going to change. We're moving very much towards mobility, maybe, rather than just purchasing cars.
I can't wait any longer. I'm going to have to jump in and have a go. Thanks, Paul.
Thanks very much for coming.
So I'm inside the car. I'm pressing the start button, as you would in a normal car as you jump in the morning. I'm putting myself in gear in an automatic mode, and I'm off, and I can already feel the environmental factors. I can feel the vehicle. It does feel genuinely like I'm driving a car as I move the steering wheel to the left or to the right, as I even accelerate as we go through what looks to be or should be a 30 limit, so we may have to slow down a bit. But we've got hazards to the left, hazards to the right, which we've got to avoid. And you can see how this can benefit you if you were, for example, in a public service, and you were in the police, or you were in the fire service, and you were looking at simulators like this to give you additional training, because it is so lifelike. We come up to a crossroads. We've got traffic lights. I'm on the brakes. You can feel a little skid there. We're obviously going to have to wait until they go green. And there we go. And we're on green and we're off. So driverless technology, they can use this to basically test the vehicle, to make sure that before they do any testing on roads or on circuits, they've covered pretty much all the bases beforehand. And it is, I have to say, it really is evidence of this. Oh, I've just gone through a red light, would you believe it? I'll probably have a police siren behind me in a minute, but there you go. So I'm gonna pull up here now on the left-hand side. Now this particular simulator does have motion sensors with it as well. So if you did want to feel, the car manoeuvring left to right or up and down, you can actually do that as well. It is a fascinating experience here at the WMG department at the Warwick University. In fact, it's been a fascinating day where we've learned about how the future of driverless cars and autonomous vehicles is being developed here in the UK. So the operation of the simulator is one thing, but what about what's behind it? Who developed it? I'm going to go over to Will, who's with Simon Skinner.
So Simon Skinner from XPI Simulation. Your company has built the simulator model here at Warwick Manufacturing Group. Can you tell me what technology is in it and how does it work?
Okay, we have been involved in producing training simulators throughout our 11-year history, and over time these have become more and more complex. So as a company, we produce a range of simulators from very small systems that are used by councils and road safety organisations, all the way up to large research simulators like the one that we've been involved in producing for Warwick. As throughout the company's history, we've always tried to use the latest and greatest technology, but make it reliable and stable for use in simulators that will last for many years.
So looking at the hardware and the software, as you step into the simulator, it's basically a circular box. You sit down, put on some, just talk me through the technology and what's involved in creating the simulation.
Sure. The technology behind simulators consists of a number of little pieces that all go together for the whole. So for example, projectors that display onto a seamless curved screen that really makes you feel that you're really there. Very high quality images that are produced using laser data. It's called LiDAR, which is also used by cars that are autonomous these days. So the same technology that is used in autonomous vehicles for deciding where they are is the technology we use to produce really accurate images that replicate what real life is like. Aligned with that, we use a real vehicle. So in this case a Evoque, which has been connected through to our computer systems. So all of the instrumentation, all of the controls feel like you're in a real vehicle. And our aim on all of this is to have the person who's sitting in a simulator feel like they are actually in a real vehicle, in a real place, driving along a real road. And that's really important for getting what we call transference out of the technology and getting good results in research simulators, because if the simulator isn't real enough, people don't feel that they are there and they won't behave in a realistic fashion. So our job as the technology company is to make it as real as possible.
When you look at the automotive industry in the UK, very strong on an upward trend, making lots of cars. Do you think this particular technology is really important to the future of automotive generally? We're making lots of internal combustion engine cars, we're very good at it, but where does this fit into the future piece?
Absolutely, and I think one of the key aspects of autonomous vehicles is being really sure that you can use them on existing roads infrastructures. It's not possible to build an entirely new road network where the autonomous vehicles are separated from existing manually driven vehicles. So there's a lot of confidence building that needs to happen, and a lot of research into algorithms for safety, for security, and how will existing manual drivers react to autonomous vehicles on the road. There are huge regulatory issues, and it is a confidence building measure, because the last thing you want to have is have an autonomous vehicle that behaves in a bad way. That could potentially kill the industry. So it's very important to do testing, and simulator technology allows you to replicate the same situation again and again and make sure that the autonomous vehicle behaves in the correct manner.
Now you're an expert. How long before someone like I can just go into my car drive, step into a car, start reading the paper and drive off autonomously? How long?
Well, I think the technology is there now. It's these regulatory issues, insurance, all of these other aspects of the complexity which have to be sorted out. So my personal prediction is I think in around 2030 we will see these systems on the road in widespread use, and between now and then they'll be increasing over time. Probably in urban areas first, and then in rural and on motorways later on.
I'm always fascinated to come to universities, and at Warwick University today I've learned a lot about simulation and the future of driverless cars. The WMG group have been heavily involved with this project. In fact, it's one of the first, or maybe the only project in the UK like it. And isn't it great to think that in just a few years' time I'll be able to jump in a vehicle and go from A to B without having to worry about environmental factors, in fact without having to worry about doing anything.